geometric mean between two numbers. From 8.1, we learned that the geometric mean is equal to the square root of the product of two numbers, a and b. So for example, in number 1, we have 5 and 25. The geometric mean of 5 and 25, you would do the square root of 5 times 25. I could multiply 5 times 25, but I already see that there's a perfect square. So instead of multiplying, I'm going to take the square root. The square root of 25 is 5. So a 5 comes out of the radical, and a 5 stays inside. So the answer is 5 radical 5. Number 2, 81 and 9. You do x equals to the square root of 81 times 9. Both of them are perfect squares. So instead of multiplying, I'm just going to leave it as it is and take the square root of 81, that's 9. And the square root of 9 is 3. 9 times 3 is 27. So the geometric mean of 81 and 9 is 27. For number 3, x equals the square root of 7 times 5. Pardon my 7. And that is equal to the square root of 35. My goodness. Okay, the square root of 35. For 20 and 3, do x equals the square root of 20 times 3. And you get 20 breaks down to 5 and 4. 4 is a perfect square, so a 2 comes out of the radical. A 5 and a 3 stayed inside, so you multiply those together and you get 15. So 2 square root of 15 is the geometric mean of 20 and 3. Now for number 5, 12 and 5, we do x equals square root of 12 times 5. 12 breaks down to 4 and 3, so 4 is a perfect square. So a 2 comes out, and a 15 stays inside. So this one's also 2 square root of 15. And that is how you find the geometric mean. You multiply the two numbers together and take the square root. You can simplify the radical before you multiply. So we didn't actually multiply 5 times 25. Here we took the square root of 81 and the square root of 9. Here we couldn't take the square root of 7 or 5 because they're both prime. So we just multiplied them together and your answer is square root of 35. Here we broke down the 20. 5 and 4. 4 is a perfect square, so that came out of the radical. And 5 and 3 stayed inside. Same thing here.